This video deals with the turning point of quadratic graphs. Remember, quadratic graphs have parabolic shapes like this or this, like a U or an N, as you can see here in red. Now, turning points, there are two types of turning points we are interested in. There are two. The turning points are also known as stationary points in some text, but the word more commonly used for the WIAC specification is a turning point. Now, the two turning points we are interested in: the maximum point and the minimum point. The maximum point of a graph or a quadratic curve is the highest point. Maximum, highest. This is easy to remember. So we have a quadratic graph here. The highest point, the point itself, is known as the turning point. This point has coordinates. Just like we described in the previous video, we have y-intercept and x-intercept. The y and x-intercepts are points on a graph, and these points have coordinates. Here we have a maximum point here, the highest point on this curve. It has coordinates. Here for this curve has a minimum, the lowest point on the graph. And this point also has coordinates. So the maximum point is the highest point on the curve, and the minimum is the lowest point on the curve. That's very simple. So that's the first thing to know. So when you plot a graph, for instance, on graph paper, you only plot a couple of points. You might just plot this point, this point, this point. You might not even plot that point. You might plot, let me show you something. Oh yeah, actually, I'll do that. This is very important. So say you had a table of values for the whatever this equation is, and you were plotting the points. You could have this point, you can have this point, you can have that point, you can have this point, you can have this point, you can have the point here just on the side of the maximum point, but you may not actually plot this maximum point. You might just plot the point next to it, and then you will join up your curve and you might get the line. Sometimes you might just join it up and you might not even, you might go too high or you might go too low, and you might not actually get the point. So there's a technique, there's an analytical technique for determining the maximum point so that you don't make errors while plotting, and I'm going to show you that next. So for a given quadratic equation, an equation of the form y equals ax squared plus bx plus c, you must be tired of me mentioning this form where a is not equal to 0. The x coordinate of its turning point can be determined using a formula, and that formula is x star. That formula is x. I put an asterisk next to it, but it's x equals minus b over 2a. Now, every point on a graph has an x coordinate, but now I'm using an asterisk next to this x to show that this x, I'm going to call this x asterisk, refers to the x coordinate of the turning point. Now, a quadratic curve, for the purposes of WIAC maths, within the scope of your syllabus, a quadratic curve will have either a maximum point or a minimum point. Now, we are just trying to determine the coordinate of the point. This doesn't tell us whether it's maximum or minimum. To determine whether it's maximum or minimum, we might have to sketch the curve to see the shape. If it's a shape like this, we know that it has a minimum. If it's a shape like this, we'll know it has a maximum. There's also another shortcut formula for telling just from the equation, but I'm just not going to go into that because that's outside the scope of your syllabus. So key thing here is quadratic curves have turning points. Now, without even sketching, this formula will tell you x coordinate of the turning point, and using the x coordinate you can determine the y coordinate, and therefore you have the full coordinate of the turning point. And I'll give you an example. So note x star, or asterisk rather, is equal to minus b over 2a, where b of course is the coefficient of x in the formula for the quadratic equation, and a is the coefficient of x squared. So here's an example. Here's an example question, and it says determine the coordinates of the turning point of the quadratic equation y equals x squared plus 24x minus 4. This is a quadratic equation. It's of the form y equals ax squared plus bx plus c, because this minus 4 is the same thing as plus minus 4. So c is minus 4. But we're interested in the values of a and b. A is the coefficient of x squared, which is 1, because this x squared is the same thing as 1 times x squared, or 1x squared. B is the coefficient of x, which in this case is 24. We're required to determine the coordinates of the turning point. Coordinates are made up of an x coordinate and a y coordinate. And I've told you that the x coordinate of a turning point of an equation is given by minus b over 2a. Therefore, we can say that the x coordinate of the turning point of this equation is minus b, 24, over 2a. A is 1. 2 times a, 2 times 1, which is minus 24 over 2, which is minus 12. So now we know the x coordinate of a turning point. What about the y coordinate? Well, the turning point is a point on the curve. So say this curve has this shape, I'm just guessing. It's a point on the curve. And every point on the curve has an x and y coordinate. And the x and y coordinates are such that they satisfy this equation. The x and y coordinates are such on the x and y coordinates on the plot of an equation. So on a curve, for instance, satisfy the equation. We have the x coordinate, minus 12. To determine the y value, you just replace x with minus 12 in the equation. So let's do that. Y equals, instead of x, we have minus 12 squared plus 24 times x. Instead of x, we have minus 12 minus 4, which simplifies to give y is equal to, what's minus 12 squared? That's 144 plus, what's 24 times minus 12? That's minus 288 minus 4. Simplifying this gives minus 148 as the corresponding y value to this x value of minus 12. Remember, we use this formula to determine the x coordinate of our turning point as minus 12. So we have the x coordinate. Good. For the y coordinates, you have to find the corresponding y value to this x value. You replace x with minus 12 in the equation to determine a y value. So we have y is equal to minus 148. And that's the y coordinate of the turning point. So now we have the full coordinates of the turning point. Now we don't know whether the turning point is a maximum or it's a minimum. We can determine that if we sketch this graph. But we now know that the turning point has these coordinates. Here's another example question. Same kind of question. When you're required to determine the coordinates, the x and y coordinates of the turning point of this equation. This equation has a graph, which is a quadratic curve, and there's a maximum or minimum point. We don't know which one, but we want to determine the coordinate. Now, formula for the x coordinate of a turning point is given by minus b over 2a. And once you determine the x coordinate of the turning point, to determine the y coordinates of a turning point, so I'm going to call that y with an asterisk, you replace x in the equation with the x star value you obtained. So you're basically going to have x star all squared 8 x star plus 5. So this is the procedure. Now we have our equation y equals minus 2x squared plus 8x plus 5. In order to determine the x coordinates, x asterisk, we need to know what b is and we need to know what a is. Now our equation is y equals minus 2x squared plus 8x plus 5, which is of the form y is equal to ax squared plus bx plus c. By comparing the equation we have with the general form of a quadratic equation, you can tell that a, the coefficient of x squared, is minus 2. b, the coefficient of x, is 8. Therefore, x asterisk, which is the x coordinate at the turning point, is given by minus b over 2a, minus 8 over 2 times a minus 2, which is minus 8 divided by 2 times minus 2, so minus 4. Minus cancels minus, 4 here 1, 4 here 2. Therefore, the x coordinate of the turning point is 2. So I can say for our x coordinates, we know the x. For the coordinates, we know the x coordinate is 2. Now, what about the y coordinate? So actually, this is what we're looking for. Well, to determine the y coordinates, I'm going to use a different color here because I'm just going to follow this equation here. Y coordinate is given by minus 2 times x star squared, which is 2 squared, plus 8 times x star, which is 8 times 2 plus 5. So the y coordinate is minus 2 times 2 squared, which is 4, plus 8 times 2, which is 16, plus 5. We have y asterisk, because minus 2 times 4 is minus 8, plus 16 plus 5. So we have minus 8 plus 16 plus 5. 16 plus 5 is 21. So we have minus 8 plus 21, same thing as 21 minus 8, same thing as 13. So y star is 13. Y asterisk, sorry, is 13. Now we have the coordinates of the turning point of our graph. 2 as the x coordinate and 13 as the y coordinate. And that's all. So the key thing to remember when determining the coordinates of turning points is you have this formula to determine the x coordinate. It's easy to remember, and once you know this, so you need to remember the formula. Once you know the x coordinate, you determine the y coordinate by replacing x in the equation with x asterisk, and you get the y coordinate of the turning point, and then your coordinates are complete and you're done.